Okay, guys, this problem is a little different because we're not asking you for a formula. We're asking you now for the equation. Here's where it gets fun, because we need to remember a few things about equations. And the first thing we need to remember or understand is, what is a parent function? So let me write this on the side. So a parent function is basically the original graph, of every exponential graph. Like, first one, y equals x to the power of 1. Everybody remembers this graph because it's the original straight line. And our original straight line crosses through 0. So that's the original parent graph for y equals x. If I were to give you for the quadratic, y equals x squared, that's the original for x to the power of 2. And that's basically when it crosses through 0, it's a parabola going up. That's the original. For x to the power of 3, y equals x cubed, the parent function, again, is still crossing through 0. It's crossing through 0, but it's crossing it like an x, like an s. So basically, the parent function is basically the equation that has actually no numbers except for the exponent. Well, today, this doesn't look like any other parent function except for this one. Y equals the square root of x. And y equals the square root of x is going to cross through, you guessed it, through 0, but it's actually half a parabola sideways. So our parent function is the square root of x. And it looks something like this. I'm going to use a different color. It's crossing through 0, and it goes like that. That's the parent function. Okay? Well, let's use this parent function to do the first thing. Let's get to g. G right now is the green line, the green graph. And this point, I would say that's a -3. I would say that my x is -6, my y is -3. Well, if I'm at 0, 0, what do I have to do to get there? Well, let's figure it out. If you guys don't remember the formula, we go something like this. It's going to be the square root of x, of course. But if we're going to put something with the x, look at this again. If we're going to put something inside the x, that's how much you move side to side from left to right. We call that horizontal. And there's always a minus. If you're going to write something outside of the x, we call that the vertical shift. That means it goes up or it goes down. So with that information, first let's see what's going to go inside with the x. In this case, inside the square root. Don't forget there's a minus always. So to get to that point, how many do I need to go left? If I were to use, let's go with green here. How many do I need to go left to get to that point? Well, if I'm at 0 and that's -6, I went 6 left, or in other words, -6. You see that? Now, to get to that point up there, I need to go from 0 to +3. Well, that will be 0 to 3. That's +3. That goes on the outside. You see that? Well, that's our graph for g of x. Now, to do the f of x from here, now let's create an equation for f. All right, simple enough. Well, if we're right here, I want to get to this point. This point is my x is -4, my y is -3. Well, how many did I need to move to the right? If I'm at -6, I want to get to -4. I went +2. So to move side to side, I'm just going to add a 2 to this guy, right? And to go down, how many did I have to go down here? I was at +3. I went to -3. So I went 3 to the 0. 3 more down, that's a -6. So my new graph for f of x will be the square root of x minus -6 plus 2. That's a -4. And then +3 minus 6, that will be a -3. And that's our equation. If you wanted to simplify it, I mean, we could. Just call it the square root of x plus 4 minus 3. And I'm actually going to show you how this is true. So let me show you with our good old friend, Mr. Desmos.com. It's actually pretty fun here. Let's show you the square root of x. That's the original. And if I were to give you the square root of x minus -4, take it out of the square root, -3. Isn't that the f of x, the red one? Aren't we at -4, -3? You betcha. And if we write the other one, the square root of x minus, where's the x? X minus negative 6. Take it out of the square root. Plus 3. Isn't that our other point at negative 6 and 3? You got it. So, I mean, it doesn't matter if you want to simplify it. It's still going to be the same look. Plus 4, nothing changes. This one, x plus 6, same thing. Desmos recognizes what you're doing. And that's basically what you do with these.